Hello and welcome to Talking Points. I'm Dave Kelly, Director of Advanced Media Production at Cal State Long Beach. Today we're going to talk about building a sustainable future through using the tools of engineering. My guest today is Dr. Hamid Rahai. Dr. Rahai is the Director of the Center for Energy and Environmental Engineering and Services. Welcome, Hamid, and thank you for joining us on Talking Points.
Thank you so much. Thank you for having me.
Well, when we talk about sustainability, it's a word that's used a lot today in the media and in society in general. And for the purpose of informing the viewers, what we mean by sustainability, it's usually defined by three different metrics. The first one is environmental first. Something has to be environmentally sustainable in order to be a practice that we can continue. Secondly is the financial aspect of whatever we're doing. It has to be affordable. And then finally, there's a social ramification that goes along with sustainability too, that if whatever we're doing is putting a particularly large group of people or a socioeconomic subset of people in our community at a major disadvantage, that can become unsustainable and has to be addressed as well. So given that those are the sort of broad parameters of what we mean by sustainability, let's talk about engineering and what sustainability means when we look at it through the lens of engineering and engineering standards. What is that?
So in engineering, when we talk about sustainability, we are talking about applications for sustainability. In other words, our focus is on energy consumptions and emissions. So whatever we can do to reduce energy consumption and emissions and waste is related to sustainability. Let me give you some examples. We focus on energy, as I mentioned. We focus on waste. We focus on agriculture. We focus on land use or reuse of the land. So all these areas require engineering interventions to reduce energy and reduce emissions. In the area of energy, we have energy productions, we have transportations, we have industrial productions, we have food productions, we have cement productions, we have gas and oil production, all kinds of productions. We look at these production and industrial processes to see what can we do to reduce energy consumption and subsequently emissions. In the area of waste, what can we do to reduce waste? We have wastewater, industrial waste, we have plastic waste, we have agricultural waste, we have food waste. What can we do to reduce landfills and reduce waste? In the area of industrial process, can we look at the sequence of operations to see if we can come up with a new way of productions, a sequence of, or adjust the sequence of operations to reduce energy consumptions. In the area of agriculture, we look at all aspects of agriculture, from cultivations to harvestings to feeding the cattle and all this. What can we do to reduce greenhouse gases and also reduce energy consumption? So overall, engineering is focused on reducing energy consumptions and reducing emissions for a sustainable future.
And so that would obviously assume that engineers have to take the lead when it comes to recycling, for example.
Yes.
And also, you already mentioned reducing waste, but also what about preserving water and preserving precious metals and that sort of thing? How do the engineers take the lead on that?
Well, we look at it that sustainability should be in every aspect of engineering design and operation and processes. Industrial production, manufacturing, of any kind of manufacturing that we do, mining, designing buildings, every aspect of engineering needs to incorporate sustainability. That's what. So when we talk about net zero and green buildings, it should be part of engineering. So when we talk about production, it should be part of the sustainability, it should be part of engineering, design, and so on. So when we have made a lot of progress in certain areas in terms of recycling, in terms of the reuse of the materials, in terms of the way we apply sustainability to buildings. But we have a long way to go. in this area. To give you an example, for example, in buildings, we use energy-saving appliances. We use water recycling systems. We have these technology available. We have better windows and window covering. When you look at these buildings, we have applied a lot of engineering common sense to reduce energy consumptions. However, there are other things that we can do. For example, in California, it's a warm climate, and when we want to look at the sustainability, we need to look at the orientation of the buildings. We know that if we have a building in north-south orientations, we reduce sun exposure, direct sun exposure. That means that we reduce energy consumption. Also, if we are using renewable energy and we are looking at placing solar panels on the roof, when we have north-south buildings, we have higher solar intensity. That means the energy production would be higher. So there are other things that we can do to increase sustainability in the process of the engineering processes. But you know that we have made some progress and a lot more needs to be done.
We'll talk about building construction again in a moment, but first I want to talk about manufacturing. And it seems to me that one of the things that engineers can do right now is to develop new machines and new engines in the manufacturing process. This would be for the assembly lines as well as for the finished products of machines that are being built. How can engineers design those machines so they can be more energy efficient and operate with less impact on the environment?
First, we have to understand that in manufacturing and production, we have a lot of old plants, old buildings, old processes. So the first thing that we have to do, and this applies, Southern California is a major manufacturing center. So for us to be able to tackle sustainability in California, we need to look at these old manufacturing plantations or plants. So in order to do this, we need to do energy audit of these manufacturing plants. So what do we need to do? Can we come up with a way to change the sequence of operations or with maintenance to reduce energy consumption? Can we come up with a way that with the minimum investments and retrofitting reduce energy consumptions? Do we need to put major capital investments in this to change the productions completely to a new way of production with 3D methods and automation and so on? The buildings that house these manufacturing, can we look at these buildings and also look at this to see that if we can have energy savings with these, with these buildings? So there are a lot of things that need to be done for the old or manufacturing buildings and manufacturing processes. But as we move toward new way of productions, we need to incorporate new technology. New technology including powder metallurgies, including additive manufacturing, including 3D printings, all kind of 3D printings, will help us to reduce the number of iterations that we need to do to produce the products. That means we save energy. Many of these machineries are energy efficient as well as we go through this. So overall, if we move toward production with advanced technology and updating all those as we proceed, then we save energy.
So updating plants and installing the newer technology will, in and of itself, help us along the way. And as you said, 3D printing and some of those technologies are much more efficient in terms of creating things in the manufacturing production line. Let's talk about the Southern California goods movement industry here, because as we know, it's a major part of our economy. In fact, it's a major part of the U.S. economy, exactly. What we do here in the San Pedro Bay. And the California Air Resources Board and the state of California have decided to impose zero emissions mandates for operations in the San Pedro Bay and the harbor area, because a lot of, as we have determined through studies, a lot of the pollution that affects the Southland is coming from the harbor area, both the ships in the harbor as well as the vehicles and the numerous trucks and so forth that are needed to move the goods out of the harbor. So what can we do in the harbor area, and what's going on right now in terms of innovations to make the harbor much closer toward that zero emission goal?
Well, first of all, for the last decade, 2 decades, with community advocacy and investment by the port and state and federal government, we made great progress in reducing emissions of goods movement. So there are electrification of the port. That means allowing the shippers to switch to shoreline electricity during their stay here at the port. That means they are not running their auxiliary engines. That means they reduce emissions. Speed control. So slowing speeds means reducing energy consumption and reducing emissions. So there is a speed control in place when the ship enter the harbor and leave the harbor. There are investment in using electric trucks, electric cargo handling equipments that in place right now. But remember, all of these requires more power, more electric power. If those electric power comes from renewable sources, we have made great progress. If not, then we didn't make that much changes. Remember, ocean-going vessels, when they are at sea, they use bunker fuels. Bunker fuel is the dirtiest and cheapest fuel. That means they produce a lot of emissions. And we know emissions travel long distances through the wind to other communities. So we need to come up with the newer technologies and fuels with less carbon intensive to incentivize them to switch to this new technology and so on, and fuel, to reduce global emissions if we want to really address sustainability at the ports. Moving toward future automation would be a major thing. We have talked about automations, but automation is a very difficult subject at the port. So in order to come up with a process that we can reduce backlog so we don't have so many ships waiting to come to dock and unload their cargo or load their new cargo and so on. In order to do this, we need to be much more efficient. Efficiency is with automation, so we can have better goods movement and delivery, at the same time reduce emissions and less energy consumptions.
So when we talk about automation, there's been a concern about how it affects labor. So in 30, and this isn't very fair, but I'm only going to give you 30 seconds, how do we deal with the issue of automation and how it impacts labor?
It's a long process. Automation is a long process that requires re-education and reinvestments in the labor to transition those labors to a new labor that can support automations. And that is required a generation of educating a new generation of the labor that come. And I generally don't call them labor anymore. These are technical advisors and technical support people that come and learn the machineries and learn how to support automations. That investment has to be there before we transition to automations.
And on that note, we do have to go to the break. When we come back from the break, we will talk about building construction in Southern California. Stay tuned.
Great having you.
Incredible women.
I wish they had those kind of cool careers for women when we were growing up.
So in this flashback, we're all the same age?
Yeah.
What does everyone want to be when they grow up?
If I say 2 jobs, do I get extra credit?
No.
I want to make immersive video games. I want to revolutionize 3D printing. I want to analyze data from the cloud.
I want to be a meteor.
You mean meteorologist?
No.
That's great, Al. Follow your dreams.
For the record, I was a baby in the 70s.
Welcome back to Talking Points. I'm Dave Kelly, and my guest today is Dr. Hamid Rahai. And Hamid, before the break, we were talking about the Southern California goods movement industry, which is centered mostly in the San Pedro Bay. And the fact that that has been an area of major concern for the California Air Resources Board and the state of California for reducing emissions. And they have established the zero emission mandate for about 10 years from now, roughly. And you were talking about some of the ways in which the port has automated and so forth, but I think we need to talk for just a moment about emissions and what we've done about the emissions there, particularly with the NOx. So explain to our audience what NOx means and how have we reduced it?
Yes, nitrogen oxide is a major emissions when we use compressed natural gas and when we use diesel fuel. So over the years, we have reduced carbon dioxide significantly. We have reduced the particulate emission using scrubbers and filtration process significantly. However, NOx has been a challenge for us. In recent years, if you look at the engine manufacturing, Cummins, which is a major engine manufacturer of the trucks, came up with a CNG engine, compressed natural gas engine, with low NOx emissions or near zero NOx emissions. And the way they do it is that they actually have exhaust gas recirculations. That means a portion of the exhaust coming and injected at the intake of the engine to reduce the amount of oxygen in the engines and reduce NOx. We also have came up with a humid air system that you can inject humidity to the intake of the engine at the saturation level. And with that, we were able to reduce NOx emission by 60%. So there are advanced technologies that's coming and processes that coming that will help us to reduce NOx emission at the port.
And that's good news for everyone. We all breathe the air, so we all want it to be as clean as possible. Let's talk about construction and building construction. You had mentioned that in the earlier segment. And so engineers are definitely taking a look at construction from a new perspective, I think, because of the way they're positioning the buildings and the way they're incorporating, as you mentioned, the location of the building versus facing north or facing south, so that the heat of the summertime is not as severe. And also when you place the solar panels on the roof, they have to be facing largely the southern sky and things of that nature. So let's talk about that for a moment as far as engineering and how engineering is going about reimagining the process of building homes. And do we have to actually deconstruct the whole construction process from the way it was done before so that we can do it a new way?
One of the major parameters in building housing and building any kind of commercial and residential housing or a structure is sun exposure. We need, in warmer climate, we would like to reduce sun exposure. Direct sun exposure causes increase in energy consumptions. So orientation of the building, as I mentioned before, reduce direct sun exposure. In colder climate, obviously, we need sun exposure. We take advantage of that sun exposure to heat the building so we can bring down the energy consumptions. So what we have done is that we try to position the structure in north-south so we can have reduced direct sun exposures. We have the way that we orient the windows and doors actually reduce direct sun exposures. We have used overhang to reduce sun exposures. So we have used, for example, fans in the attics to reduce sun exposure or the heat that we gain through the roofing, so we can reduce energy consumptions. So there are many different ways of reducing. Another approach is that a cool roof. If you paint the roof with reflective paint, you can reduce the energy gain that caused by direct sun exposure, and this way you can actually reduce energy consumption of the buildings. Or we can have a garden, a roof garden. A roof garden actually reduces the energy consumption of the buildings. So there are many ways to incorporate this, but they are not mandated. These are the things that is practiced as much as possible, but it is not a requirement. So we need to come up with a way that educate people, educate engineering community, and make this a requirement that if you want to have any kind of a structure, sustainability should be part of that design, part of that construction process. And in constructions, we're talking about recycling. We are talking about reducing the number of miles traveled in order so we can use a local vendor for supplier. We can recycle not only the construction material from the existing building, but also we can also recycle the water that we use. We study the noise, the environmental impact of constructions. So we need to really look at all of these in any construction project.
You mentioned a term earlier, net zero.
Right.
So when we use the term net zero, what does that mean?
Well, whatever we produce, we use. So at the end of the day, there is net zero energy consumption or net zero from supply, energy that's come from the utility companies. So what do we mean by that? Is that we have renewable energy resources in the building that produce energy for the building, and we use that, all of these, during the daily usage of the energy. And a net zero or a green building has energy efficient appliances. It has energy recycling, water recycling systems. It has, energy efficient doors and windows and building structures and building materials. It uses a lot of green spaces to be able to reduce the impact, the environmental impact of the operation of the buildings. So all of these are, when we talk about the net zero or green buildings, are part of a green building or green structures. But it is really hard to have a net zero building, especially when we talk about residential buildings. So let's look at, in Southern California, we would like to have a net zero buildings, residential building. And in general, the average consumption, electric consumption of a residential housing is about 25 kilowatt hour daily. In order to produce that much, we need to have about 500 square footage of the solar panel on the roof to be able to produce that much energy, assuming that on the average we have 5 hours of intensive solar radiations. Most of our roofing does not have that kind of a space and that kind of area to be able to put solar panels. So it is not really possible at this stage to produce net zero residential buildings, although it should be part of the design and permitting and other things like this. But commercial buildings, it is possible. So we might be able to do it with a lot of manufacturing plants, a lot of commercial buildings, at least partially offset energy consumption through these renewable sources.
Let's talk about residential building and construction and what we're looking forward to in the future in that area. And during the pandemic, a lot of people became familiar with the idea of telecommuting and working from home. Mm-hmm. And so they wanted their homes to be as comfortable as possible since they had to live there and work there at the same time, more or less. So in the future, when we design buildings, what have we learned from the pandemic? Is it more energy efficient to distribute power and electricity and so forth out to lots of different small buildings? Or is it more efficient to have people centralized in buildings where people go to work? What have we discovered, and how will that affect construction in the future?
Well, we have to realize a major parameter in assessing sustainability in structures or in building any projects is vehicle miles traveled. So any projects that we design, any community that we design, any structure that we design, we need to look at it to see that how does that impact vehicle miles traveled. VMT is not just about energy consumption or how much fuel we are using. It's not about that. It is about the number of accidents that we will have. It is about congestions. It is about traffic. It is about infrastructure repair. All of these are part of these assessments of any projects. So if you are talking about distributed energy in a form of this, expanded residential, single family residential, how does that impact this VMT? And if we have a lot of apartments, high-rise buildings, and concentrations of the populations at certain location, how does that one impact vehicle miles traveled, VMT? So it is not a simple answer to say that this one is better than the other one. It is looking at the, when we design a community and high-rise buildings and multi-story buildings and so on, that what kind of services we are providing, how close they are to work, what can we do in terms of the public transportations, accessibility of public transportation to these buildings, and so on, what kind of green space we can create. All of these are factors that in reducing VMT, and also in that how we do assess this project for sustainability. So you mentioned that telecommuting or working at home. Yes, telecommuting is a great thing. Working at home is great things because it reduces VMT. If it reduces VMT, that it's going to help out in terms of the not only energy consumption, but also it will help out in terms of reducing congestion. It help out in reducing accident and traffic, and reducing the structural repair, infrastructure repair, and so on. So all of these needs to be estimated in changing the habit and changing the process of working and traveling to work and production, everything.
Time really flies. We only have about 1 minute left in this segment. So in that minute, I'd like you to talk about engineering education, because the way we train or educate the engineers of the future obviously makes a huge difference. What are your thoughts about the way we are teaching or training engineers at the collegiate level, and are there some improvements that need to be made there?
So over the years, we have incorporated sustainability in engineering education, but our core education has not changed. And unfortunately, we do not incorporate sustainability in every part of our educations. And the initiative should come from accreditation board for us to be able to change, because we design our curriculum based on the requirements of the accreditation board. So in order to change and teach sustainability from freshman all the way to senior and graduate schools, and incorporate sustainability in every course that we teach, we need to have initiative from accreditation board to be able to do this, to be able to match that requirement so we maintain accredited. Give you an example on this is that...
We've only got about 20 seconds left.
Okay, let's look at the coding. We do a lot of coding, right? Programming. We need to incorporate sustainability in coding. In other words, that not only we design a code to do something that we want to meet the end objective of this, but also design to use less energy for executing that code. So this is, and there are many other examples that we can incorporate.
And on that note, we will have to end the program because we've just run out of time. But thank you for being here today.
Thank you so much.
And thank you for joining us on this edition of Talking Points. Be sure to join us again soon for another episode. Until then, I'm Dave Kelly. Have a nice day.